Welcome to Mastering Fire Alarm System Design. This comprehensive guide covers the principles, codes, and practices essential for protecting lives and property through effective fire alarm systems. By the end of this training, you will understand key codes like NFPA 72, identify all system components, apply core design principles, and learn the basics of installation and commissioning. The primary mission is life safety. Systems detect fire early, alert occupants for safe evacuation, notify emergency services, and activate other building systems for containment. All design begins with the rulebook. NFPA 72 is your fire alarm Bible. NFPA 70, the National Electrical Code, governs wiring. Always check the local building code for amendments. Design requirements vary drastically by how a building is used. A theater, a hospital, an apartment, and an office each have unique detector, alarm, and placement needs. There are two core system types. Conventional systems use zones. Addressable systems give each device a unique identity for precise location and advanced diagnostics. Smoke detectors are the system's nose. Photoelectric types excel at sensing smoldering fires. Ionization detectors respond faster to flaming fires. Choose based on the expected fire type. For challenging environments, use heat detectors, either fixed temperature or rate of rise. Flame detectors, which react to light spectra, are reserved for high-risk industrial settings. These pull stations allow human intervention. They must be read, visible, and installed along all exit paths, with a maximum travel distance of 200 feet. Audible alerts, horns, speakers, or bells must be heard. Public mode provides a general alarm. Private mode allows coded signals for staff. Sound levels are strictly regulated. Visual strobes are required for the hearing impaired and noisy areas. Their intensity, measured in candela, determines coverage. Strobes must be synchronized to prevent disorientation. In complex buildings, voice systems provide clear, intelligible instructions. They direct occupants safely and are mandatory in high-rises and large assembly spaces. This is the system's brain. The FACP monitors all devices, displays system status, normal, alarm, trouble, supervisory, and provides primary power and control. Reliability is critical. Systems use a dedicated primary circuit. Backup batteries must provide 24 hours of standby plus 5 minutes in alarm. Generators offer further redundancy. A modern system doesn't work alone. It interfaces with elevators for recall, shuts down HVAC to control smoke, releases door holders, and monitors sprinkler systems. Design follows a disciplined process. First, analyze codes and risks. Then, lay out devices and zones. Perform circuit calculations. Finally, produce shop drawings and specifications. Placement is rule-based. Follow the manufacturer's listed spacing, typically 30 feet for smoke detectors. Adjust for ceiling height, beams, and avoid dead air spaces near peaks. Zoning organizes information for responders. Limit zones to one floor maximum, with no more than 20,000 square feet. Always designate stairwells as separate zones.
The message must be received. Sound must be 15 decibels above average ambient noise. Strobes must be visible from anywhere in the space. Calculate candela ratings carefully.
Designing NACs requires calculation. Sum the current draw of all horns and strobes on the circuit. Account for voltage drop over distance. Never exceed the panel's rated output. Conventional IDCs require an end-of-line resistor systems use integrity. Both must be monitored for open and short circuit faults. Voice design prioritizes intelligibility, not just volume. Formal testing measures the speech transmission index for clarity. For high-rise voice systems, circuits must survive a fire. This is achieved using 2-hour fire-rated cable or by routing critical circuits through physically separate pathways. Your design is communicated through shop drawings. These include floor plans, riser diagrams, calculations, and a legend. They are legally required for permits and installation. Installation turns plans into reality. Follow manufacturer guides. Use neat, supported, and clearly labeled wiring. Acceptance testing proves the system works. You must test on 100% of devices per NFPA, verifying in a form of reliability requires ongoing care. Perform weekly panel checks. Check batteries annually. And remember, smoke detectors need internal cleaning every 5 years. Avoid these mistakes: ignoring ambient noise, forgetting HVACs on smoking, poor zoning layouts, and undersighting calculus. Attention to detail saves lives.
This is your solemn duty. Your design protects lives. Stay current with codes.
Fire alarm design is a critical, code-driven discipline. Master these fundamentals and NICE certification. Thank you for your commitment to life safety.